Now, actually, just before we do, so I don't forget, let's see who's here. Mahmoud? Yeah. Okay. Gafar? Yeah. Amjad? Zara? No. Okay. Mo? Daniel? Savi? Okay. No Savi. Sabrina? No? Okay. So I already have 1, 2, 3 people. Alfreda? No. Arya? Yeah. Judy? Yes? Yeah. Young Peng? Amna? Mariam? Okay, so 3 people missing from that group. And then Michelle? Michelle?
Yes.
Yeah. Abir? Autumn? Autumn? No. Celine? Yeah. Sophia? Mubarak? Yeah. Yeah. Chadira?
Yeah.
Mohammed? Sabrina? No. Okay. Moza? No. Angela? Ahmed? Safra? Lucas? Not sure, he's gone, isn't he?
He's gone.
Isn't he?
Yeah.
I haven't seen him since we came back. Yeah.
He left before the exam. Is it?
Huh?
Is it possible to ask for the semester 1 grade, like exactly how much, or?
You can arrange to see me in the office, we can look at it. Yeah. Okay. Leave the poor fly alone. The poor little fly. It's not going to do...
Huge fly.
Okay, it's pretty big, but it's not going to harm you. Right. Now, what we're having a look at now. Guys, leave the... It's not going to do anything to you.
It's distraction and thereby harmful to our education.
It's an anti-learning fly. Okay. Right. Oh, come on. Just ignore it. Right. Now, what we're going to have a look at now, histograms. Guys, this is something which, it comes up actually in your biology exam, doesn't it? Except they screw it up in the biology exam, they don't do it properly in that. Have you done these yet in biology? No. Okay, so I'll show you the proper way to do it. So usually what happens is you already have your data put into a grouped frequency table. So usually the start is we have our data like this. Whatever it is, maybe we're measuring something, we'll call it X and it's measured in milliliters, and then we have how many we have, our frequency. So just to keep it short, I'll just have 3 boxes just to keep it short, but it doesn't really matter. So let's see. The first one we'll just say is 0 to 10 milliliters. And then the next one is 10 to, let's just say 20. Well, maybe I can get in one more. 20 to 30. And then 30 to 40. And it's closed on the left and open on the right. So closed, open, closed, open, closed, open, closed, open. Okay? Let's put in some frequency. Let's say 2, 3, 3, 1. Yeah? Now, frequency is a little bit like a bar chart, for those who've seen bar charts before. But there's one big difference between frequency and bar chart. Does anyone know what that big difference is? Yeah, what is it? Yeah, that's it. So with the bar chart, you're allowed to do something like this. But you're not with a histogram. They have to be continuous like this. Okay? So I think that's maybe something that is not appreciated in the biology, perhaps.
What do you mean by continuous?
That the bars have to touch. So on the x-axis, we have our data. And in this case here, it's pretty clear. It's 0 to 10. So there's 0, 10, 20, 30, 40. But the question then is, what do we put on the y-axis? Now you actually have choices here. There's 3 different things you can put on the y-axis. 3 different things. The first thing you can actually just put is the frequency. Okay? But I never do this, and I don't think they ever expect you to do this in the exam. This is perhaps what you do in biology. Okay, so this is like the baby level. Now, the more advanced level is you put something called the density, and I'll explain what that is in a moment. And then at the very top, you put what's called the normalized density, or the, I'll just write it as normalized here. I'll explain each of these, don't worry. So you have 3 of them: frequency, density, and normalized density. So I'll explain the 3 of them now. So if you were to put the frequency, you don't need to draw this part down, because this isn't really for the exam. If you were to put the frequency, you would need to go up to 1, 2, 3. Yeah? So the first one would be, what would that be? 2, and then 3, and then 3, and then 1. And they all touch like that. Okay? It's not usually that. The most common one for the exam, I think like 99% of the time, is something called the density. And the density, the formula for it is the frequency divided by the width. So how wide is this interval? 10. So 2 divided by 10. Try again, Amjad. 2 divided by 10. 0.2. Yeah? 1 over 5, yeah. 3 divided by 10. 0.3. 0.3, and the last one is 0.1. So what's the biggest number here?
0.3.
Yeah, so do you realise you actually are not really doing anything much different in the shape here for the density? Because it still looks the same, doesn't it? There's 0.2. Then the next one here is 0.3. There you go. And then this one here, 0.3. And the last one is 0.1. Now, you might say, well, what's the advantage of doing that over, say, the frequency? Well, to answer that, I just want you to calculate something for me. I want you to calculate the area of each of these rectangles. Okay, it should only take you a minute. So you know the base, you know the height. So write down the 4 areas here, please.
Why does it always go down at the end?
Well, not always. It's usually most data it does. Yeah.
The third box, shouldn't it be 3 over 20?
The third box?
Yeah.
3 over 10. It's 20 to 30.
It's the graph.
The width.
Oh, okay.
Yeah?
Is that 90? All of them?
Yeah, what's each rectangle's area? There's 4 rectangles.
No, it's 2, 3, 3.
Yeah, what's the first area? 2, and the next one? 3 and 1. Now you've seen those 4 numbers before.
That's the frequency.
It's a frequency. And that's the key thing. That's like the point here, if you want to really put that in a box here, that the area here represents the frequency. That's the key point here for these types of histograms. Yeah? Is that okay? Now, you might say, well, what's the advantage in that? Let's pretend you didn't have the histogram. So if I go back to the table like this just for a moment, and I said to you, how much of my sample is between 28 and 35? leave the little thing alone. You don't know, that could have been reincarnated as something important beforehand now. So, just be careful, okay? Right, suppose I ask you how many is between 28 and 35. Well, you can't really answer when it's like this, because you don't have a box that's between 28 and 35. However, when you have this histogram, what you could do is mark off 28, mark off 35, and we've just learned that the area represents the frequency. So now you could answer how many is between 28 and 35. So the frequency between 28 and 35, okay, what's the area of this one? That's 2 times 0.3, so that's 2 times 0.3 is 0.6, isn't it? Plus, and then this piece, how big is that? 5 times, what's that? 0.1, that's
half.
0.5, so that's 1.1. So there's roughly 1 data point between 28 and 35. So there's about 1 between 28 and 35 milliliters. That's something you couldn't answer quite easily in the table.
The data must be not secret, the secret is right.
It's only an estimate. It's only an estimate. Yeah? Got that? That's a typical exam question. Part 1 is draw the histogram. Part 2, they'll ask you something like, what is the frequency between 28 and 35 or something like that. Something that you can't answer from the table. Yeah? Continue, guys? No? Okay. So if you want to give things a little bit of a name here, this type of histogram where we have area as the frequency, that's the most common type used in maths for this course. That's called a relative histogram. The next one I want to show you, it's not likely to be on the exam, but it's possible to be on the exam, is the normalized one. And the first one, which I didn't show you, is only in the biology exam, where you simply put the frequency as the height. Okay? What are you doing in biology at the moment?
Mitosis.
So you have you done any graphs? Just line? Okay. Right, let's look at the next type, which is normalized. So normalized, I'll just, oh, by the way, that symbol, does anyone know it for density? Yeah, rho. Okay. Can I just remove these 4 numbers here? Yeah. Guys, can I remove this? Yeah. Okay, so the next one we'll do is the normalized histogram. So instead of a rho here, that's a P. So the only difference now is what you use. Well, actually, I think I should have kept the other ones because I still need those numbers. So let me keep them. I'll just write both. Rho and P. I'll just squish it in here. I'll draw a new. Oh, japers. Right. Sorry. I did not give myself enough space here. Let's delete this. Yeah. Messy. All right. What were the numbers here? 0.2, 0.3, 0.3 and 0.1, wasn't it? And what do these all add up to? 0.9. 0.9. Yeah. So in the normalized histogram, what you try to do is, oh, and actually before I continue, what do these ones add up to? 9. These ones add up to 9. So what you try to do in the normalized one is you try to add it up to 1 then. Yeah? Okay, that's going to be, let me think. Let me just write this down. Rho is width over frequency, and P is, let me think.
It's frequency. Yeah, the other one. The row. It's not width over.
Oh, sorry, I have it upside down. Thank you. Frequency over width. And then P, let me just think what it is.
0.1.
I think it's frequency over total frequency over width. Yeah. I'll show you why it is that in a moment. Can we calculate that for each of these? So the first one would be 2 over, what's the total here? Total frequency? 9. No, the frequency, 9. So it's 2 over 9 divided by 10. So what's 2 over 9 divided by 10? It'll be pretty small. 0, point,
0.
and a few 2's. Okay. Okay, we'll take that. What's the next one? 0.033, isn't it? The next one? 0.033. And the last one? 0.011. Okay?
Yeah, that doesn't add up to 1.
No, I'm sorry. I told you a dirty, filthy lie when I said this adds up to 1. I'll show you what adds up to 1 now. So that was a dirty, filthy, lie. Can I scroll down? Okay.
So what does it represent?
Yeah, we'll see what it represents on the graph now. Can I scroll down? Yeah? Okay, let's draw this now. 0, 10, 20, 30, 40 milliliters. Oh, what was I? Milliliters, wasn't it? Yeah. Now, here is P. Now, this is a little bit harder to draw. What's our biggest number here? 0.033, isn't it? So I think what I'll do is I'll go 0.01, 0.02, 0.03, and then the last one, 0.04. Right, what's the first height? 0.022, is it? So that would be like around about there. And then the next one? 33? So that would be there. And then the next two are the same, isn't it? And then the last one? 0.11, which is there. Okay, let's calculate the areas. So again, the first one here, it's 10 multiplied by 0.022, isn't it? So what's that? 0.22. Okay, the next one, what's the area? It's 10 multiplied by 0.033, isn't it?
Yeah.
So what's that one?
0.33.
33. And then this area?
Same thing.
And then the last one would be
0.11.
0.11. Now if you add them all up, you'll get, yeah, roughly 1, because we have to round off some of these. So what do you think this could represent if the total is 1? And I'll give you a little hint. Look at the letter I used. Yeah. So here, the area represents probability. So if I asked you, what percentage of the sample is between 0 and 10 milliliters? What would that be? 22%. What percentage of the sample is between 20 and 30 milliliters? 66%. Between 20 and 30. Between 10 and 30?
10 and 30 is 30, but you said 20 and 30.
Are you sure? I could have sworn. No, this is recorded.
Yeah.
Okay. I could have sworn I said 10 and 30. All right. What percentage is between 10 and 30?
66.
66%. Yeah. So this is but this one's a little messier to draw and calculate because the numbers are so small. So I've never seen them ask you this in the exam. It's never come up in the exam. The only one that has ever come up and always comes up is the last one we did here. Okay, so you really, of all the histograms, this is the one you have to draw in the exam most likely. So just to recap there, your first choice is you just use height as frequency. Your second one, use the height is the frequency divided by the width. And the third one, the height is the frequency divided by the total frequency divided by the width. This one here is only in bio exams. This one here really, it's going to be 99% chance that it'll be this one in your maths exam. But there's still a 1% chance that it might be this one. I really doubt it because they haven't asked it. But just in case, this is the formula for the height in the last one. But this is the one that you'll most likely need.
Could you go up by a bit for a second?
To which part now?
To the table.
This table?
Yeah. So you know that point 3, point 2, point 3, point 3, and point
Yeah.
1 all add up to point 9. Yeah.
Yeah.
So and do you want them all to add up to 1? So couldn't you do that? Point.
What I'll add up to 1?
All like you want it to all add up to 1.
This part?
Yeah, the area.
Do you want the area to add up to 1?
Yeah. You want the area to add
Yeah.
up to 1. So couldn't you do that? So couldn't you do it as? One second.
Now you see, you're asking, no, stop. I'm hitting the pause button. If you don't have the question fully formed in your head, stop. I don't like when students ask me and they're forming the question at the same time. So once the question is fully formed in your head, then you can ask me. Is it fully formed?
Okay. So
No. Is it fully formed?
I know what I'm trying to say.
No, I don't believe that's fully formed. I'll give you 5 minutes to think about it and then you can ask me once it's fully formed. Alright? Once it's baked for 5 minutes, then we'll test it. Okay. Do you have these 3 formulas down? Yeah? So actually, just a note. Do you notice in the 3 histograms, you still get the same shape?
Yeah.
Which is kind of really what's most important of all. And in case you're wondering, do these need to be the same thickness? What's the answer here? In my example it is, but do they need to be?
No.
They don't need to be, they can be different. Where this is not the case with the bar chart. With the bar chart they all have to be the same thickness. Well, for the histogram they could be different. So like, I could have another box which is, what's the last one here? 40 to 50, is it? I could have another one which is 50 to 80. So it means on my histogram, what would happen is I'd have one more bar which would be like this at the end. That's fine. That's not wrong. Yeah, it just needs to be no breaks. No breaks. In the exam, they always seem to make the thickness the same though, that I've noticed.
Good.
Yeah, which it makes things a little bit easier, especially if the thickness is something easy like 10. So it's all easy to calculate the heights here. Okay. Let's just have now, go for it.
Okay, so what I figured out is that the way I solved it for the question I was going to
Yeah.
ask is there's another way to solve it that will also give you the right answer.
Yeah?
But I'm pretty sure I solved it wrongly and on accident I reached the right answer. So what I did was I was thinking about taking 0.2x, 0.3x, 0.3x, 0.1x
Yeah?
and create them all to 1 to figure out what the multiples so that you could get the area. But instead of taking 0.2, I took 2, 3, 3, and 1, and I got the right answer, which is a multiple of 0.11. If you see,
Oh no, I don't want to see anything.
It gives you the exact same
I
answer.
think the easiest answer would be no, don't do this. And just use this formula here. Because in the marking scheme, it will give you a mark for this. For having some formula for calculating the height. In fact, sometimes they might ask you to first calculate all the heights before graphing. So they have to give you some mark for using a formula. I think this is really what they want to see. Anyways, it's just this formula here. It's unlikely it'll be that one. Okay? Right. Anything else with these? I'm sure a lot of you have seen these histograms before, haven't you? Yeah. This is the question in the exam where they would expect you to do it on the graph paper. So in the exam, the final exam, usually 90% of the time there's a graph question where they ask you to do this on graph paper. So it's commonly the histogram, but there are other types of graphs and statistics that they could ask you to do. So you've done one already with column, haven't you? A line chart or something, was it?
Line graph.
A line graph? Yeah. What did he use as the line graph? Like, what was the example?
It differs.
Come on, get off the phone. I'm asking you a question. What did Column use in his example of the line graph?
It differs. The hardest one was the log. to be honest.
Yeah, he gave us a log graph once.
Yeah, so what was on the X and the Y?
Can't remember. That was ages ago.
Do you remember any example he did? Nothing.
Time or is that enough activity?
Activity.
Time?
No, time on the
Hmm?
not
No.
activity, time and activity on the Y.
You remember
I think it's some
on the Y
yeah.
and on the X? Time. Yeah.
Or
Heat.
temperature. Yeah.
Yeah, no, I was just checking because in biology you can be careless with your graphs. If it's called a line graph, it really should only be time on the x-axis. So, but like I said, also you should do this, which is not great in biology as well. And in fact, the person who writes the exam doesn't know the difference between a bar graph and a histogram, because sometimes they've asked the biology students to draw a histogram when they meant a bar chart, and a bar chart when they meant a histogram. So, yeah.
It seems professional.
It's yeah, it's a problem. It's a problem. Okay, so there's a few minutes left. Can you please try and draw these neatly in your notebook? Because again, I'll say this again. This is going to be the graph question in the exam, which means you have to use graph paper, which means you do get marks for being neat and accurate. Okay, so try to be neat and accurate. For goodness sake, try to use a ruler at least. Okay. Right, try these for a few minutes.
In the final exam, do they focus mainly on semester 1 or semester 2?
I'd say it's about 60-40, 1 to 2. It's good that way.
Very uneven ratio.
Yeah, it's 60-40, I'd say.
Although semester 2 is way longer than semester 1.
No, it's a little shorter.
Shorter?
Yeah. It's just we have courseworks to do and things, you know.
Do we have another course?
What?
Another one of those, like...
I haven't looked at it yet, to be honest.